Alright, Chapter 4, Section 2 is all about taking air and how we can separate air into the different pure gases that make up air. So for example, we use a process known as fractionation of air. It separates air into pure nitrogen, oxygen, and pure other gases. To do this, we cool the air, and then by doing that, the water and the CO2 pretty much become solid and they fall to the bottom. The remaining air, which is mostly nitrogen, oxygen, argon, a couple other noble gases. What we do is we compress that air 100 times more than normal. We cool it, we let it expand. We do it again, and you do it again and again and again, and eventually that nitrogen, oxygen, and argon combination will eventually turn to a liquid. Then it's really easy to separate the gases because each gas has its own boiling point. All we really have to do is just raise the temperature slightly to different boiling points, and let's, for example, if you raise temperature just a little bit at negative 196 degrees Celsius, the nitrogen will turn to a gas and that will separate from the liquid. Then we raise the temperature again, and then you get negative 185 degrees Celsius, and then the oxygen turns into a gas, and we can separate that from the liquid that's left over, which will probably be like argon and the other noble gases. And like I said, we just keep doing this, raising the boiling point in order to get each gas by itself. Helium can also be done doing this. However, getting helium out of air is really expensive. So we do the same process, but we just use natural gas like propane and butane and methane because there's a lot more helium found in those kinds of gas preserves or reserves in the ground. Pure oxygen is used in steel making, rocket propulsion, and other controlled reactions. Liquid nitrogen, I mean, whenever we send anything out of space, that's using liquid nitrogen as fuel. Liquid nitrogen is really cold, really cold. In fact, we call that cryogens, which means Greek for icy cold, and it's very dangerous because if a canister of like oxygen was to open up and pour on something, even if it was metal, that metal would just instantly freeze and become really brittle. So it's very dangerous stuff. Some of you might have heard of cryogens, like cryogenically freezing. You know, there's the story that Walt Disney has his head frozen for somehow get it thawed in the future. I don't know how they're going to do that when you chop someone's head off, but who knows? We'll see what happens in the future. Nitrogen is also used for things for welding, for example. And they make like an atmosphere of nitrogen because the oxygen in the atmosphere will react with the metals at high temperatures, and that's not good. We don't want that to happen. Nitrogen is very inert. It doesn't really react with metals. So that's why it's awesome to use nitrogen atmospheres for welding. Liquid nitrogen is often used in medicines, specifically to remove warts or even other kinds of like skin cancers. My dad gets melanoma sometime. It's a type of skin cancer. He goes to his doctor and they just put liquid nitrogen on his skin and it freezes off the cancer. Now it causes a big sore there because I mean when someone pours liquid nitrogen on you, it's like an instant frostbite. It just kills the skin. It just kills all the cells. So I mean, it's like almost getting burned in a way. Just the opposite of burn. It's just frozen. Because of its low temperature and inertness, liquid nitrogen is also widely used in frozen food preparation and preservation during transit. Because again, it's really cold, so it keeps everything nice and chilled. Nitrogen is also an essential element for plants, but plants can't take in pure nitrogen. So hopefully you learned this in biology during the nitrogen cycle. But nitrogen fixation occurs, and that is a process by which atmospheric nitrogen turns into different compounds, and then those compounds get dissolved in the water, and then the roots from the plants absorb those compounds that have nitrogen in it, and that's how plants get their nitrogen. Noble gases are often used for, like you guys know, neon signs. Argon is used to provide inert atmospheres, again, kind of like welding. They put them in incandescent light bulbs to help the filament to last longer, and other things like that. Helium, everyone knows what helium is used for, pretty much for balloons. And there you go. That's it. That's how we take air and separate it into its pure different gases.